Hello and welcome to our lesson on radical square roots. First, let's talk a definition. The value of a number, or sometimes when you have a variable, that when you multiply it 2 times in a row is going to equal the inside number or the radicand. So take a look. This inside number right here is 64 and the index is 2. Now, we would say that we need to find the square root, or sometimes we say the second root, of the number 64. We're looking for an index of 2 with a radicand of 64. So much like when we find the simplest form of a radical, we have to make a factor tree of the radicand. So we're trying to find the numbers, prime numbers, that created 64. You can start with any 2 numbers you want. You could start with a 2, you could try to do a 4 if it works, whatever you want. 1 and 64 wouldn't really help you because it doesn't break it down at all. So let's do 2. 2 goes into 64 32 times. 2 is a prime number, so we can stop there. And I like to put a little dot under my prime numbers so I can keep track of them. Then I have 32, not prime, so that goes 8 times 4. Neither of those are prime, so we need to break down. 2 times 4. I got a prime. Now I need to break down 4. It's going to be 2 times 2. And then I need to break down my other one as well, my other 4, into 2 times 2. Whew, that's a lot of stuff. So we have 2 times 2 times 2 times 2 times 2 times 2. We have 1, 2, 3, 4, 5, 6. 6 2's multiplied in a row, and those are all primes, and they should create the number 64. Now, just like I said, 2 times 2, and it's 6 times in a row. Pairs go out, and singles stay in. In other words, because we were looking at a square root or an index of 2, we need to pull out numbers that are in groups of 2. There are 3 groups of 2, because we have 1 group, 2 groups, and here's the one with the other guy up here. So that's 3 total groups of 2. So they all go out, and nothing stays in. Now, I've got 1 group of 2, 2 groups of 2, 3 groups of 2. I only write them 1 time to show that they're grouping. So 2 times 2 is 4, and 4 times 2 is 8. So what does our answer look like? Well, the 8 was our 2 times 2 times 2. That was a pair of 2's, second pair of 2's, and a third pair of 2's, and you multiply all of them together and you get 8. The index was 2, and notice there's absolutely nothing underneath the radicand sign because there were no singles left. They all grouped up. So because of that, you can leave out the radical sign. If you've got nothing to put under the radical sign, you have no radicand, don't even write it. So your final answer would just be the number 8. Let's take a look at another one. In order to do these, you have to go ahead and double check. So the new whole number outside of the radical sign, that number 8, you're going to take it and multiply it by itself the number of times the index says, which was 2. Then we would multiply whatever answer we got by the radicand. However, in our answer, we didn't have a radicand, so there's nothing more to multiply. Now, the way you know you've done it correctly is that the number that you get from your double check should match the original radicand that you were trying to solve for. So let's take a look. We had the whole number of 8, so we're multiplying the whole number 8 the number of times in the index, which was 2, right there. So they're asking us to take 8 and multiply it by 8. Now we multiply that answer, which is 64, by whatever is in the radicand, which is nothing. So we just stop there. Does this original radicand that we first started working with, does it match our double check number? It did. It was a 64, so we did it correctly. Now, let's try this. We have 108, and we need to take the square root of that. So let's start with a factor tree. I've got 108, and I know since it's an even number, I can break it into 2. And if I divide 2 in there, I get 54. I know 54 is not a prime yet, so I got to keep going. So I'm going to have 6 and 9. 6 isn't prime, so I have to keep going. I have a 2 and a 3, both of which are prime, so I can stop. 9's not prime, so I know it's 3 times 3, and those are primes as well. Index says 2, which means we're looking for pairs to pull out. So I have a pair of 2's, and then I also have another pair of 3's. And this time, we do have a lonely single guy who didn't have anybody to pair up with. So that lonely single one stays inside the radicand, inside the radical sign, and becomes the new radicand. Now you're going to take the pair of 2's, you only write it once, and the pair of 3's, and multiply them by each other, and then that lonely little 3 goes back in there. Let's finish simplifying this. It's going to be 6 radical 3, and that is the square root of 108. Let's try it with a fraction. Right here I'm missing an index, so it's assumed to be 2. I'm still looking for a square root. I'm going to take them separately. I'm going to take the square root of 1, and I'm going to have it over the square root of 54. You can write it this way, or you can write it that way. Either of them are equivalent. It seems easier if you just break them up into separate square roots. So what's the square root of 1? 1, because 1 times 1 is 1. So we know that we have a 1 on top. Is 54 prime? Nope. We have to break it down. And if you remember on the last one, we did break down 54. And it was 6 times 9, which we ended up with 3 times 2 and 3 times 3. And since we're looking for pairs, we have a pair of 3s and the lonely 3 and a lonely 2 left over. So pairs come out, singles stay in, pair of 3s come out, and the singles of 2 and 3 need to stay under the radical sign. We're not done because you have to multiply them out. So the numerator is 1, and then you have 3 radical 6. This is your answer for the question of what's the square root of 1 over 54. All right. Now, how does this look when we deal with algebra? Which just means we're throwing in a variable. Not a big deal. We're going to take square root, because there's no index, so it's assumed to be 2, of 24. Let's do our factor tree first. You could do 2 times 12, 3 times 8, 6 times 4. Let's do 6 times 4. Random, you can choose whatever you want to. It's all going to end up to be the same primes. So 6 is 3 times 2, and those are primes. And then 4 is 2 times 2. So we're down to primes. Because it's square root, we're looking for pairs. I've got a pair of 2s and lonely guys left over. So it's going to be 2 on the outside. And on the inside, I'm going to have 2 times 3, which is 6. We're not done, because we still have to deal with that variable, 7 of them. If we have z to the 7th, it means that you need to write out z 7 times. Yeah, it's not the most fun thing to do, but if you don't write them all out so you have the total number, you're going to end up dropping one or forgetting one of the pairs, and it's not going to turn out correctly in your answer. Now, because this is an index of 2, we're looking for pairs. I see a pair of 2s, another pair of z's, and a third pair of z's. So I have 1, 2, 3 pairs of z's. However many pairs I have becomes my new exponent. And I have one lonely little z left over, so he goes back under the radical sign. And this would be the square root of radical 24z to the 7th. Now, if we wanted to do a double check, which we do, remember what we said? We would take the outside number times the index, which is 2. So that means 2 twice. 2 times 2 is 4. Multiply it by whatever's left over, which is 6. So 4 times 6 gets you back up to your 24. Now for this, you're taking your exponent and you're multiplying it by your index, which is 2. So 3 times 2 is 6, and then you add however many more you have, which is 1. So that's 7. Gets you right back up here. So this is correct. Now let's take a look at our last one. It has an index of 2, so that means we're looking for pairs. Let's do the numerator first. So let's break down 64, and we'll break down m to the 10th. 64 I can break down by 2's. And if I do 2, it's going to be 2 times 32. 2 is prime, 32 is not. So let's do 4 times 8. 4 is not prime. Now 2's are prime. Let's break down 8. We've got 2 times 4. There's another prime, but 4 is not prime, so we're going 2 and 2. All right, we've got a lot of 2's here. It's asking us for an index of 2, which means we're going to circle and take out of the radicand pairs. So I have a pair of 2's, another pair of 2's, and then another pair of 2's. I have 3 pairs of 2's. So that means I have 1 pair times another pair times another pair. So 2 times 2 is 4, and 4 times 2 is 8. Now we're going to take our m's and break them down. List them all out first. I know it's tedious. I know it's not the most fun thing you could ever do. However, if you list them out, your chances of making a mistake are far, far less. Now, we're looking again, the index is 2. So we're looking for 1 pair, 2 pair, 3 pair, 4 pair, and 5 pairs of m's, which means I have m to the 5th. That pair becomes your exponent. So on the numerator, you have 8m to the 5th. So far, so good. On the numerator, it's 8m to the 5th. Nobody was left over, so we don't have a radical sign. Now let's break down 16m to the 4th. 16 should look like a very familiar number. That's a perfect square. It's 4 times 4. I have a pair. I can take them out. So that's the denominator, and it stays there. Now list out, you've got m to the 4th. You've got 1, 2, 3, and 4 m's. Again, an index of 2 means we're looking for pairs. You have 1 pair and 2 pair. The number of pairs becomes the number you put in your exponent. It looks like we're done, but not quite yet, because we can reduce this. 8 over 4, isn't 8 divided by 4 2? So that makes a whole number of 2. And if you remember, when they say divide exponents, they're lying. They mean you need to subtract them. So you're going to take the exponent of 5, subtract the exponent of 2, and you're going to get an exponent of 3. So that means you have 2m to the 3rd, and that would be your fully reduced answer. Okay, so let's do a quick review. In order to find the square root of a radical expression, first we need to create the factor tree of whatever is under the radical sign, which is the radicand. All the prime numbers that can be doubled up in pairs need to be taken out of the radical sign, and any remaining singles, the ones who couldn't find a pair, have to go back under the radical sign. Any of them get multiplied together under there, and they create the brand new radicand. Be sure to go back and double check your answer to make sure that you have the right answer, so you get total credit on your stuff. And that's it for our lesson on radical square roots.